Our panel moderator is Dr. Parveen Kumar, Senior Program Manager, Electric Mobility, WRI, India. Dr. Parveen Kumar is a Senior Program Manager, Electric Mobility at WRI, India under the CITES program. Currently, he is associated with the projects related to the electric vehicle ecosystem. He has previously worked at the Indian Institute of Science, IISc, Bangalore, and has received a PhD from JMI New Delhi. He has more than 14 years of post-PhD experience in science, technology, and policy research. He has published several peer-reviewed papers in reputed journal and articles in leading magazine. Our panelist, Kshitikesh, Parmeshwar. Mr. Kshitikesh, Parmeshwar, please come on the stage and take a seat. CTO, MAHLE ANAND. He has multifaceted experience of nearly 3 decades in the areas of business development, process re-engineering, project management, operation and management. He is passionate about automotive thermal system design and development. All along his career, he worked on providing thermal management solution for automotive applications. He experienced the design and development of heat exchanger from first generation mechanical expanded to currently level of all alumni. No colloq heat exchanger. He has 8 patents and 5 technical papers on his name. Next we have another panelist, Dr. Prashant Kumar Srivastava. He is the CTO at Oorja, where he oversees the technical development. He is responsible for managing resources and personnel, improving processes, and ensuring that the company meets its targets. His expertise in computational modeling and simulation has also been instrumental in developing Oorja solution. He has played a crucial role in developing the company's proprietary algorithm that predict the battery performance and thus help in optimizing the design. Next we have Mr. Akash Gupta, CEO, Clean Electric. Akash Gupta is the CEO and co-founder of Clean Electric Private Limited, a company which deals in manufacturing of safer lithium low battery pack. Clean Electric company recently received a patent granted for direct contact active liquid cooling battery architecture. For Li-ion batteries, the architecture is exceptionally well suited for the compact requirements of 2 watt, 3 watt and swapping application and is ready to power the EV resolution. Akash earned a BTech degree from IIT BHU Varanasi, where he was an active member of Aero Modeling and SAE Club. He started his professional career at JSW Group, where he worked on EV projects, majorly focused on batteries and powertrain development for JSW e-car project in 2019. Next we have another panelist, Dr. Rashi Gupta, Managing Director, Vision Mechatronic Private Limited. Dr. Rashi Gupta journey started with an idea to transform energy technology by improving its storage applications. A lady pioneer in the momentum of advanced cell chemistry in lithium storage batteries division. In pursuit of her purpose, she started to manufacture the world's smartest lithium battery in India, also earning herself the nickname Battery Valley of India. She is the proud founder and managing director of Vision Mechatronic Private Limited, striving to continue her leadership in the field of renewable energy, robotics and energy storage technology. A woman energypreneur, strong-headed and determined to establish herself and her beloved company as a power brand among male-dominated fields. It's a lovely welcome to all the panelists, and now I am handing over this to our moderator of this panel, Dr. Parveen Kumar.
Good evening, everybody, and let me start by thanking organizing team for this event and welcoming all the co-panelists for this session.
Check.
In this session, our focus will be on thermal runaway in EV components,
Check.
prediction and prevention methods. In previous session, we saw that all the experts has highlighted this point that we need to understand the problem so that we can design the solution which helps in addressing the challenge efficiently and minimize the effort of hit and trial to come up with the solution that is more effective and efficient. So I'll start with Dr. Prashant. That in the previous session, Dr. Ramesh highlighted that we need to understand the issues at the cell level and at the component level before designing the solution, effective solutions. So what role modeling, mathematical modeling and computer simulation techniques can play in reducing the hit and trial approach to come up with the best solution for the EV thermal management in EVs as well as in the different components of EV, especially the battery.
Right. If you look at the cells and their architecture, they are really complex, and as an end, I mean what you get as a voltage is a result of various phenomena happening within the cell. And now you need to have a very good understanding of what is really resulting into the performance of the cell, and what are the various things internally happening that basically can lead to underperformance and so on. And these are the areas where physics-based modelings can really help us understanding that how the different physical phenomena happening inside the cell lead to the overall performance. Now, biggest challenge currently the physics modeling faces right now is, if you look at the typical models that we have, is something called single particle model and a P2D model. And these models essentially require lot many parameters to basically start doing anything with these models. For example, you have some various design parameters which are very much internal to the cell and which any OEM will not have access to. And also there are parameters like transport parameters, like how the lithium ion is getting diffused in the electrodes, how it is migrating through the electrolyte and things like that. All these require a lot many
engineering team does on the mechanical front for the vibration, shocks and all those things. On the thermal front, you have to do all the CFD analysis, flow analysis, especially in liquid cooled battery packs, to be able to optimize all those things, because there will be 10, 20, 30 types of permutation combination which is possible. So you cannot experiment all the 20, 30 permutation combination. So first you do it on a simulation level. But while we are dealing with liquid cooling, it's not a very streamlined flow. There is a lot of turbulence in it. So just depending on the simulation also don't work. And at the end of the day, we need to validate all the simulations with respect to the real pressure drops and the flow rates which we are getting. And then after 20-30 permutation, you do the testing for 3-4 combinations, and then you choose the best version out of that. So in this way, it reduces the time, but it will be a combination of simulation and then you do the real experiments, because these are really complex things. Like he was telling about the physics-based model and then the analytics on the data. Each and every lithium-ion cell by different OEMs is different, and one behaves in a certain way and other OEM cells will behave in a certain way. From a normal layman perspective, both are 2170 5AH 3.6 volt cell, but they don't behave the same. So real life testing, you cannot avoid real life testing if you really want to deploy a few hundred or few thousands unit at scale. Modeling is important, but real life testing becomes much more critical, because you have to give warranties at the end of the day. You have to warranty for 3 years, 5 years, 3000 cycle life, 1200 cycle life, whatever. Apart from having real life test data, it is very difficult to commit all those things. Otherwise, it's a big financial liability on the company. So at our R&D center, we have almost 50, 60 channels of cell level and pack level testing, which happens on regular basis. It consumes a lot of electricity and all that thing. But at the end of the day, you can validate all your simulations in real life test, and then you can be more confident on giving warranties to the two-wheeler OEMs or bus OEMs, and they also get the confidence when they actually come and visit your facility and see that yes, these are the cycle life testing which someone has done, to get the buy-in from them as well.
Thank you, Akash. So now my next question to you, Mr. Parmeshwar, that what kind of thermal management thing is evolving for, especially for battery in EV application? And now we are talking about the integration of circular economy into the EV ecosystem, so that we can have an efficient utilization of the resources. So whatever thermal management solutions are evolving, whether they are capable or they are means keeping this reuse and recycling friendly approach while designing the solution.
Absolutely. Thank you. Thank you very much for asking this question. In fact, I would, some time ago, I was discussing with Akash also, and discussing about the technology on which he is working. Actually, our field and Akash field is not really very different. Both of us, we are working on battery cooling system. Only the technology is different. And though everybody has spoken about battery, thermal runaway, but probably we two people are going to talk about battery cooling system and optimization. What he said is right. Simulation plays very, very important role, one-day simulation. Unfortunately, we belong to a German company, MAHLE, and we are fortunately equipped with many such facilities, not only from a thermal simulation point of view, CFD, but also actual testing. We don't get into chemistry of battery system. Our job starts from once the supplier or OEMs, they give us, this is my battery, this is the heat rejection, and now you have to work on. But that is also very, very important role from battery cooling point of view. So there are two different, I would divide into two different systems. One is a battery cooling plate, which plays very. So I spoke about the battery cooling plate. Now the coolant is taken from there to a different circuit altogether. There are two system. One is refrigerant circuit and the other one is coolant circuit, and both these two elements, they work in tandem. So depending upon the heat dissipation, dissipated by the battery, sometimes it is only the coolant system works on. You have many other components. When you set a parallel between IC engine and EV, in IC engine you have engine, and you are responsible to cool engine, and that's a pretty old system, and a lot of people, they have a lot of expertise, so we also have. But system is really not so complex. But when it comes to battery EV vehicle, it calls for many other components, and all those components, let's take as low temperature radiator, chiller, eye condenser, air-cooled condenser. Then there are other agencies too. It is not only that you have to cool all the time battery. If you take your vehicle to Ladakh or somewhere, sub-zero place, then you have to have even coolant heaters too. Coolant heater, then you have air PTs, all those, there are many new components. So what we do, we run simulation, 1D simulation to understand complete system level behavior, and then come to sizing rating of all the heat exchangers. So once the heat exchanger is done, we understand how big and what should be the size of heat exchangers. Then comes the role of system integration. That's a pretty complex, And worldwide, if you look at, not many people have experience of system integration. You have to have a system working knowledge. You have to have a set of software engineers, hardware engineers, those who would understand the complexity and balance the system such that you get optimal performance. So our target always to maximize range of the battery so that you get more and more mileage out of it.
Thank you. Now, Dr. Rashi, next question for you. That in previous session and in the other session, panelists have highlighted the requirement of strong R&D, and the technology is evolving, and with the learnings, new things are evolving, and that requires a lot of R&D support here. And now in this session, we are talking about the prediction prevention methods, where modeling and mathematical modeling and simulation can play the role. So here, it will be not possible for industry to have a strong R&D facility at their place. And between our country, we have the institutions having a very strong presence of R&D, especially on the mathematical modeling. So how, what kind of intervention can help in forming a very strong collaboration among the stakeholders so that they can bring the complementary thing on the table and address the challenges efficiently with the less time, because time is very critical here.
Thank you, Praveenji, for this fantastic question. You know, the first and the foremost thing is that we need to start valuing engineering, okay? We, over a period of many, many decades, I would say, have stopped valuing engineers and the engineering capabilities, and that's first primary reason of the brain drain that we have from our country. Number two, what you said is right, that industry and more so the startups which are coming in the EV space do not have the bandwidth or the financial bandwidth to have the entire thing to be done themselves in terms of mathematical modeling or and you know, for an entrepreneur it becomes very difficult. What should the entrepreneur or the startup focus on? The business? To get more sales, to get more revenue, or to do mathematical modeling, or to do the R&D, or to do the production, or to just, you know, go in for service support. So where should the focus of the startup be? So the point here is, we need a collaborative effort and a non-competitive collaborative effort, not just a collaborative effort. Because in India, everybody wants to do it themselves. But that's not the case abroad, where I have, I've been trained in European countries, and I've just seen that they are okay with an industry-academia collaboration, and they understand the value of engineering which is done by their academic institutions, and the result that comes is applied onto the field, and then corrective methods are done in accordance to what was the feedback that they got from the field, and that gives a fantastic, robust product. What today is lacking in the entire value chain is this non-competitive collaborative effort. Now, even if you give it to the academia, you never know what academia is actually interested in, or what will be the outcome and how many years they will take, whether it is time-bound, whether it is just for research papers and, you know, your chapter is over without actually coming out with the final concrete solution that the industry is looking at. And then the PhD people will get their PhDs, RAs will graduate, and then, you know, your project is stalled, and then you're still waiting. So the industry also has a dilemma that should I go to the academia to get my things done or not? Because industry today is running against the clock. And academia is far, far behind to what it should have been, at least to parallelly support the industry to come to a level where we could have been in a space to be at par with the developed nations. So that chain is missing. Number three, what we are not doing is we are not upgrading the faculty. So we tend to, when we tend to hire people or when we try to induct peers, more young ones, young talent, what we realize is that whatever they've learned is partially in the classroom segment and partially on the on their own through lessons on YouTubes or other channels of e-learnings. But the point is, how is the faculty upgrading themselves? The very important factor here is because if the faculty does not upgrade themselves, such kind of industry academia collaborations will not take very smoothly, because the academia will not realize what industry wants, and they will be still in their laid back, chilled out attitude that okay, 2 years project hai, last 6 months mein we will write something and give. That is not how things work. And specifically in the battery domain and the energy storage domain, if we look at, they are very, very price sensitive, time sensitive and engineering sensitive domains. So if your engineering goes wrong, you know what is the scene. Last year we have 17 lives claimed for the wrong engineering and the bad designs and the bad battery packs that were made out, and they've claimed 17 lives in the EV fires. In fact, this year also Diwali has already begun. We've had 3-4 cases till now already. So the point is, academia can definitely help, but they need to step up their game. Industry needs to open up a little bit, and also there has to be a service model in the industry academia collaboration, which is not predominantly prevalent today. It is more of a capex incentive intensive kind of model where some revenue sharing and stream sharing works between industry academia. Both interests are protected. But the thing is, if you can have a service sector coming in from the academia, industry and startups will find it more easy and access. Okay, you have a problem statement, X number of hours, X number of revenues, your answer is here. Something like that, that will give industry I mean, I can take it stepwise. I can get the results stepwise and I can also progress. You cannot have the whole thing done in one day, and mathematical models are definitely very, very important. Like when we started, in my company, we are the pioneers of doing preventive and predictive monitoring. All of this IoT based things are now. We did it in 2015. And that's why we have the world's smartest lithium battery, because we did all the AI, preventive, predictive monitoring, data analytics, IoT right since 2015, where we implemented everything on field, on ground. It was very challenging for us. We never had anybody talking about industry academia collaboration back then. At least now somebody is talking, so that is good for the startups to take up these things effectively and get the support, because it's a win-win situation for both industry and academia to come together and create a new model. Because now the time is, if we really want to become Atmanirbhar Bharat, the view that we have, and not just Atmanirbhar Bharat, but even somebody who can be a reliable source of good technology, good products from our country to the global level, then we need to have a very robust industry academia collaboration, where academia is running a parallel track with the industry, hands in hands, and giving out the results.
So I think this message will, I think the stakeholders will take this message and do something positive on this. Due to time constraint, we will be not able to take the other question. I will be not able to ask the other questions. But thank you all of you for joining for this panel discussion. And we'll just conclude this session with this. Thank you.
Praveenji, I would just like to double click on one particular aspect. There has been 3-4 discussion, but this one point was missed in all the 4 discussions. The thermal runaway in the lithium-ion battery packs happen for just 3 reasons, and there is no fourth reason to have a thermal runaway in a lithium-ion battery pack. And there are some myths also that fast charging leads to safety issue. So first thing is short circuit. A short circuit between a cathode and anode can get the battery pack into a thermal runaway. It could happen due to mechanical destruction. It could happen due to lithium plating or the dendrites, which will puncture the separator and get to the cathode anode, and or a mechanical crush. These three things, short circuit happens. This is the first reason of fire. The second reason of fire will be overcharge. If you overcharge a cell beyond 4.2 volt, whether it is any cell chemistry, it will catch fire. That's the second reason. Third reason is overheating. So it does not matter whether it's a LFP battery pack or a NMC battery pack. Tata Nexon also catch fire. Two Tata Nexon has caught fire. Those are
So here
LFP.
actually problem is like there is a limitation at the material level, and there is a pressure from the performance requirement, and if you don't do the proper trade-off, then you will end up with this kind of accident. Like, you know that how much C rate you can go with the particular chemistry, and if you abuse that, definitely you will see the Diwali in the battery packs.
Right.
And if you don't like the BMS, BMS is the heart for this, like a policeman sitting on the cells. Brain. And in the small battery packs, people are using a simple electronic circuit just on off, as Anant was mentioning in the previous session. So of course this kind of compromise will lead to the serious challenge. So one effort is required that stakeholders should understand the problem perfectly, means at reasonable level at least, to take the proper decisions.
The previous conversation, Ram Prasad brought up a very good point, where he was saying that, even if it ceases to run, it's good, because we have prevented that event to happen, right? So if there are enough safety measures in the BMS, if you happen to prevent it, it's good actually. I mean, even though in the first place it looks like something wrong has happened, but we are safer enough. Yeah.
Yeah, so with this I think we should conclude the session, and thank you so much.